Now let's take a look at some photos. These are more just examples. These aren't something I'm going to be quizzing you on, but these are just kind of to show how different layers vary from place to place. And so here we have, all these are courtesy of Dr. Timothy Brothers, so much props to him for loaning these to me. But in this image here from Massachusetts, the soil signified by the red and the brown colors, those would be what we would refer to as the true soil, has developed in glacial till since the most recent ice age. The red tones that you kind of see there are probably from iron oxides, and so you have some chemical weathering going on there, which is causing those irons to oxidize and turn that reddish color. The dark colors at the top would be more of that humus, that finely decayed organic material. And down at the bottom is that unweathered parent material that you can see there in that black box. The soil of cold, wet climates commonly have a thick organic horizon, which decomposes very slowly in the cold climates and the slightly acidic conditions created by the coniferous trees. And so beneath this, you can see this grayish layer. It's a grayish layer of quartz sand that's been stripped of a lot of its certain types of minerals. And farther down, you see certain layers of clays, but then you see the sandy soils, the very high sand content down below. And like we've said before, pine trees, they really like the sandier soils. And so this is typical of what we would find in the boreal forests of Canada. And Dominican Republic, located in the Caribbean, gets a ton of precipitation. And so here you get a high amount of leaching. And so this is one more reason why agriculturally the tropics aren't that great. And so they're not too sustainable because of the heavy amount of leaching. The nutrients don't stay for too long there at the top layer. Below, you see this tilted sedimentary rock, which is tilted due to plate tectonics. And so plate tectonics have tilted that sedimentary rock, that developed these distinct layers. And since those layers developed, uplift has occurred, causing this slope. Warm, wet, tropical climates are commonly deep, but very infertile because so much of the water removes many of the plant's nutrients. It's also very rich in a lot of the secondary minerals such as clays and oxides, and those oxides then, in this case, this is basaltic or igneous rock, which of course this is from Hawaii, and Hawaii is based off of igneous rock, volcanic rock that's cooled and hardened, and that rock contains a good amount of iron, and that iron then interacts with oxygen and gets oxidized or rusts and turns into this certain color. And so that's what creates this very, very red tone. Another country that has a good amount of volcanic eruptions in its geologic history is New Zealand. And so New Zealand has this, in this case, this volcanic rock that we see here in this white box. It's pumice is the porous volcanic rock that we see here. Agriculturally, this is actually quite productive, and so this volcanic rock is actually pretty darn good for vegetation. It grows pretty lush forests and grassland areas as well. This showcases soil development in arid regions or dry regions, which is limited by lack of water. So the vegetation cover and organic matter are often very sparse, chemical weathering very slow, and the downward movement of weathering and decaying products is very limited. So the soil horizons are very, very hard to tell. They're not too distinct, and the entire profile isn't too deep at all, as we can see here. So this is from the Snake River Plain in southern Utah. And so what we see here is the effect of vegetation is quite evident on the photo on the left. The soil on the right is developed under a grassland in which the roots have helped to diffuse and add a little bit of organic material deeper down. But you can see how it's there's not much of a soil profile here in these dry, arid areas. With New Jersey being closer to the coast, of course, it's going to have a higher sand content in the soils. And so what we see here is a distinct layer of these distinct soil horizons that have developed on top of an old sand dune. And so, of course, that sand dune and this layer is going to have a distinct effect on the vegetation above.